Today's lesson is pretty much the backwards version of yesterday. So yesterday, we started out by knowing we had parallelograms and then saying, what does that tell us? If we know we have a parallelogram, what kind of features can we know about? And we learned that we could know about opposite sides, we could know about opposite angles, and we could know about diagonals bisecting each other. Today, we are going to say, if we know some features about a four-sided figure, are those features enough to say that it's a parallelogram? So it's kind of the backwards version of yesterday's lesson. So we have some theorems here. We're not going to prove them today, but we have some theorems that many of them are actually converses of yesterday. So the first one says, if both pairs of opposite sides in a quadrilateral are congruent. So quadrilateral, I got four sides, and if I know that both sets of opposite sides are congruent, then that thing has to be a parallelogram. We talked about that one yesterday, but backwards. We said if we know it's a parallelogram, then we can know opposite sides are congruent. The next one says, if one pair of opposite sides is both congruent and parallel, then it has to be a parallelogram. It must be the same pair of sides that is congruent and parallel. It doesn't work if one set is congruent and the other set is parallel. Right? It has to be the same set of sides that is both parallel and congruent. And that will be enough to say that we have a parallelogram. Theorem 6, if both pairs of opposite angles are congruent, then it is a parallelogram. We talked about the converse to this one yesterday. Said if we know it's a parallelogram, we can know opposite angles are congruent. This one says if we know opposite angles are congruent, then we can know it's a parallelogram. But we have to know both pairs. Knowing one pair is not enough. And 5-7. If the diagonals bisect, then it is a parallelogram. So we talked about this one yesterday as well in the backwards version. But if we know that both diagonals are being cut in half, then we can know it's a parallelogram. So that was 4 new theorems. Those theorems, along with the definition, give us 5 ways that we can prove we have a parallelogram. So if in a problem you are trying to prove you have a parallelogram, so the last thing in your proof is going to be like ABCD is a parallelogram, the reason has to be one of these 5 things. The reason has to be that both pairs of opposite sides are parallel, which is the definition of a parallelogram. Definitions work both ways. So if it's a parallelogram, opposite sides are parallel. If opposite sides are parallel, it's a parallelogram. That's our definition. The other 4 are theorems that we just talked about. Both sets of opposite sides congruent. One set of opposite sides parallel and congruent. Both sets of opposite angles congruent. Both diagonals bisecting. Okay? Those are the 5 ways that we can say that our four-sided figure is a parallelogram. In your homework, you will be doing some proofs, and you'll be trying to prove you have parallelograms. So one of those 5 things has to be your goal. In your homework, you will also be doing some problems that give you pictures and ask you if they are parallelograms, and if so, which one of those reasons applies. So we're going to do some examples of those here. We're going to start in the upper left-hand corner and work our way across and down. So from that top one where I know 2 sides are 8 and 2 sides are 12, is that enough to say it is a parallelogram? And if so, which reason?
Can I say it?
Sure.
5, 4.
Okay. Yes? I'm going to ask you to not use the numbers because when it comes to the test, I don't want you to have to memorize what does 5-4 say, what does 5-5 say, what does 5-6 say. I'd rather just have you say what it is that we're seeing. In this one, we're seeing opposite sides congruent. I think that's easier than having to memorize a list of numbers.
Wait, would we use that in a proof?
Yeah, that would be like our last thing. So if we were given this picture and we were asked to prove it's a parallelogram, then our last step would be like ABCD is a parallelogram, and our reason would be opposite sides congruent. The second one, we got 9s on top and bottom, and then we got the little arrows there.
Yes, because of opposite side are congruent. Opposite sides are congruent and parallel. Yeah, one pair.
One pair, congruent and parallel. So that was the second theorem from today. I don't know what number it is, and I don't want you to memorize numbers, but that was our second theorem today, that if one set of sides is parallel and congruent, then that is sufficient to be a parallelogram. Third one across the top. Do we have sufficient information there? So what do we know? We know one set of opposite sides is congruent, and we know one diagonal is being cut in half. But we don't have any theorems that say one diagonal and one side. We either need to know both diagonals or we need to know both sets of sides. So this one is not enough information. We can't mix and match. So we either need to know both sets of diagonals or we need to know both sets of sides. We can't know one of each.
If that was given to you, is there anything you could do to eventually prove
No,
it?
we would need more information to be able to continue on. It might still be a parallelogram, but we would need more information to be able to continue on. From that information, there's no way to say that it is. All right, going back to the left side, but in the middle now. Is that one enough?
Yes.
Yes.
Yes. Why?
Because
If
the
diagonals
bisect
are
thing,
inside
the
parallel,
bisect thing.
Diagonals bisect.
Parallelos are- it's parallel.
That was the very last theorem from today, that the diagonals are bisecting. Center, center. Is that enough?
Yes, because of the opposite angles are congruent.
We know 70 is congruent to 70, but what about the other ones?
It's not.
We don't necessarily know those. So this one is not enough. We know one set of opposite angles is congruent, but our theorem says we need to know that both sets of opposite angles are congruent. We don't know anything about the other pair.
No.
Third one across the middle is almost the same, except it gives us one more number in there.
No.
So if that other angle is 110, then this works. Do we have any way of knowing what that other angle has to be?
Yes.
Yes.
How?
Opposite angles are congruent.
Opposite angles of a parallelogram are congruent, but we don't
I
know
say
if it's
no.
parallelograms.
Because the interior angle measures have to add up to 360 degrees.
Inside of a quadrilateral, a four-sided figure, we learned back in chapter 3, we need to have 360 degrees in total. So if there's four sides, we have to have 360 degrees in total. So we can see how much do we have so far. We have a 70, a 70, and a 110. We add that up and we get 250. So if we're supposed to have 360 altogether, that one must be 110. And now, in fact, we can say that this is because opposite angles congruent. Inside of a four-sided figure, you need 360 degrees. Bottom left, we've got a couple of parallels and a couple of right angles. Is that enough information?
Yes. Yeah, we have the two right.
We have two right angles. We have two parallels.
Yes.
So how would this work if it works?
Oh. Because all the angles on the inside have to add up to 360, and both sides are congruent 90, and then the other ones would be 90s also, and then
The other ones together have to be 180.
yeah.
But do we know that they each have to be 90?
Because they can be
No.
Yes, because they're parallel and same side interior angles have to add up to 180.
Okay.
So they have to be 90.
Yeah,
So we
that's-
have parallels, and I said before, when I've got parallels but lots of other lines in the picture, I like to reduce it down to just my parallels and one more line in the picture. So if I draw in just the one side, then if it's perpendicular on one end, it has to be perpendicular to another parallel. So we know then that the upper corner has to be 90, which means the other corner has to be 90 as well. And then there are actually two ways of proving this according to our reasons. We could say opposite angles congruent, because 90 is equal to 90. Or, if these are all 90s, what does that mean about the other sides? Not necessarily congruent, they are. But by knowing they're 90s, we would know that they're parallel. So we could also say that this is our definition of parallelogram, that opposite sides are parallel.
Instead of saying same side interior angles, could you have said because they're parallel and two of them are already 90, the other two would have to be 90 because if it's perpendicular to one parallel line, it has to be perpendicular to the other.
Right, which is pretty much right at the bottom, but you can't do them both at the same time. You have to do them one at a time. And say because it's perpendicular on the left side bottom, it has to be perpendicular on the left side top, and likewise for the other ones. You can't do them both at the same time, but it is the both, same reason for both of them. Middle one. I know one set of sides are congruent, and then I have a couple little angles there that are congruent.
Vertical angles.
They're not vertical, but they are special angles. What kind of angles are they?
Even
AIAs. Okay, so if I draw out those AIAs,
Man, you're struggling with this.
AIAs make some parallel lines. Which lines are going to be parallel?
Top and bottom.
The top and bottom.
Yeah.
Is that enough information to say that this thing is a parallelogram, and why or why not?
No.
No,
Why not?
because you don't have the, I don't know,
Upside
yeah,
down
I'll explain.
lines.
You don't have the other sides, I guess.
I do have a theorem that says a pair of sides parallel and congruent, and I have a pair of sides
They're not the
parallel
same
and
one.
congruent,
They're not on the same.
but they're not the same pair. So this is not enough information.
It's close.
It's close. We do have one pair parallel and we have one pair congruent, but that theorem says that it has to be the same pair that is parallel and congruent, and in this one it's one pair of each. Last one. What do we think about that one?
Yes.
See?
If so, what would our reason be?
AIA, congruent parallel.
Okay, well, AIAs give some parallels. That won't be a reason for this thing being parallel. But I have some AIAs that will make some parallels from the single ones there. And the double marked will give me some parallels. So then is this enough information?
Yeah.
Yes.
Which is our reason?
Definition.
Definition. Both sets of opposite sides are parallel.
And you could also say because angle 1 plus angle 2 is equal to angle 1 plus angle 2, that the whole angle on either side is congruent, so it would be, oh wait, no.
That'd only be one set of angles. So that would work to get us one set of opposite angles congruent, but not the other side.
What is it? Yes, you did.
Definition. Your homework. I'm going to make an adjustment too, and then there's a little bit of a issue here. The adjustment is that I'm going to remove problem 14
Alright.
and remove problem 20.
So it's just
Come
19.
on more. We want more.
So it's 1 through 5 and 19. And then on the next page of your packet, there are 3 proofs. Do those on your actual notebook paper, not on there, even though there's room, because if you rip off that page, the next day's notes are on the back of that page, and that would be a bit of a problem. So you need to do those on your notebook paper. Now, here's the problem. The pictures didn't print, so you need some pictures for those. So I will get those up here, and you need to copy down those pictures.
We have 9 TJ. We have 9. What?
Thought I had those in here somewhere. Let me see. Because then you have to turn your packet in, and that's a problem because you need it for your notes. Then 1 through 5 from the book, and 19 from the book. So that is 9 total problems for you.